Alright, we are in section 12.5 where it deals with multiplying and dividing radical expressions. Here's a little quick review before we get started. Dealing with multiplying and dividing. Unlike when you add or subtract, you must multiply both the numerator and the denominator. So if you look at our example where it says a over b times c over d, we know that this equals ac over bd. And the example that they give us with variables here to your right around here where we have x plus 3 over x squared times 4 over x squared, where if you look at the numerator, we're multiplying 4 times quantity x plus 3 over x squared times x squared, which then leaves, when we distribute the numerator, we get 4x plus 12 over x to the fourth. And if you remember, when we are dealing with dividing fractions, we get a value where we leave the first fraction alone, but we multiply the second fraction by its reciprocal. So if we look at AB divided by CD, that ends up equaling AB, which stays the same, times by the reciprocal, which happens to be D over C, which then we multiply those together, which equals AD over BC. And when we're trying to find fractions in lowest terms, our goal today is to try to cancel as much as possible after operation. So let's take a look at some examples. So I have, for example A, I'm trying to find the product of 3x squared over 2x times 8x cubed over 15x. So again, my goal is to try to cancel out some our values. So if I look at my 8x cubed and my 2x, I can divide both of those, well, I can divide both of those by 2x. So if I took, and I crossed this out and I took 8x cubed divided by 2x, that would leave me with 4x squared. Okay? Now, if I take 2x over 2x, that leaves me with just 1. Here, I have 3 and 15. If I took 15 divided by 3, I'd get 5. If I took 3 divided by 3, I'd get 1. Now I have x squared over x. If I were to take x over x, I'd get 1. If I had x squared over x, I would just leave with x, which then is, like, that's all the canceling I can do. So then I just multiply across with the numerator, which gives me x times 4x squared, which leaves me with x to the third divided by 5. Let's take a look at B. So if I have 16x to the fifth y over 5x cubed y to the fourth times x squared y over 4xy. Again, first thing we're going to try to do is try to cancel out values. So I'm going to just deal with the numbers first. I can take 4 and 16 go together. So I can cancel this out to make this 1, cancel this out to make this 4. Okay? I have x to the 5th and x cubed. Cancel this to make this 1, cancel this to make this x squared, because when you're dealing with division of exponents, you're subtracting. So now I got y and I have y, so this one ends up being 1. This one ends up being y to the 3rd. I have y and y right here. Those are the same, so those end up being 1. And I got an x squared and x, so this being 1, and this being x. So multiplying this across, I have 4x cubed over 5y cubed. And that's its simplest form. This is also the answer to A as well. So if I take a look at C, C and D look very scary, very complex, but if we break it down, it really isn't all that bad once we cancel things out. When you see the numerator and the denominator looking a lot like quadratics, you can use the reverse FOIL method. You can also, if you have numerical values that are in common, you can factor out those values. That'll help you out cancel out terms. So if I look at, I'm just going to look at the 3x plus 6. Those values can be factored out by, they have a 3 that factors out into both of them. So I'm going to rewrite this as 3 times the quantity x plus 2. Now if I look at the denominator, I can factor out a 3 in that as well. So if I look at that, I'm going to take 3 divided by x squared plus 6x plus 9. And if I see I have a 3 in my numerator and a 3 in my denominator, this means I can cancel both of those to make 1. And here's x squared minus x minus 12 over x squared minus 4. So that's one step. Next, I see that my denominator in my first equation, or my first fraction, I'm sorry, can be reverse FOILed. So I'm going to have x plus 2 in my numerator, and I go parentheses, parentheses. I got x, x. The plus 9 means is that both the signs are going to be the same. The plus 6 means they're going to be positive, and the values are going to be 3 and 3. Now I look at my numerator, my second fraction. I have parentheses, parentheses, I can reverse FOIL. I'm going to have x, x. The negative 12 means that one's going to be plus and one's going to be minus, and I need to find whose product will be a negative 12, but the difference will be a negative 1. So I'm thinking it's going to be 4 and 3. And then looking at my denominator in that second fraction, I can determine that this is the difference of two squares. So I can rewrite x squared minus 4 to look like x plus 2 and x minus 2. So if I were to FOIL that out, it would give me the same x squared minus 4. So now, once I've did my factoring and my reverse FOIL, I can then cancel out some terms. See how there's an x plus 3 in my second fraction in the numerator and an x plus 3 in my first fraction in the denominator, I can cancel these. Same thing goes where I have an x plus 2 and an x plus 2. And I can't cancel out anymore, so I am left with x minus 4 times over x plus 3 times the quantity x minus 2. And there's your answer. Excuse me. Let's try C. We have 2x squared minus 9x minus 5 over 5 minus x, and x plus 3 times 2x squared plus 7x plus 3. So first off, I'm going to do reverse FOIL on my numerator, which leaves me with 2x here. I got x. The negative 5 means the signs are going to be different, and the negative 9 means it's going to be larger. I'm thinking, let's see, probably 5 here and 1 minus plus. Yeah, that should work. I'm going to leave my 5 minus x times x plus 3 over, I'm going to reverse FOIL the bottom, so that gives me 2x, x. Both of them are going to be pluses. I need it to be 3 and 1 here. Okay. So I have an x plus 1 in the numerator, I have an x plus 1 in the denominator, so those cancel. I got a x plus 3 and x plus 3. So now I'm left with this x minus 5 over 5 minus x. Now they look fairly similar, but I can now rewrite this equation by saying negative x plus 5. So it looks like x minus 5 over negative, oh, I'm sorry. Oops. Needed the eraser. Alright. X minus 5. I'm sorry. I wrote that incorrectly. So then that means that x minus 5 and x minus 5 cancel out, so the answer to this would be a negative 1. I apologize for the incorrect writing of the expression. And one more example for products. I got 4x squared over x squared plus 3x minus 10 times x minus 2. And if you ever are dealing with one that has a fraction and one that does not, I can always just rewrite this as over 1, if that helps you. So with that, looks like the only thing I can rewrite is the denominator in my first fraction, so that's with parentheses, x. The negative 10 means it's going to be a plus minus. The signs are going to be different. I need to find a product that's negative 10, but it gives me a positive 3. And I'm thinking it's going to be 5 and 2. So I got x minus 2 and x minus 2. Those cancel. And that's all I can do, so I'm left with just 4x squared over x plus 5. Okay. Let's look at some quotient problems. So, again, if you're dealing with fractions with division, all we do is multiply that second fraction by its reciprocal, and then we just do it, same rules apply once we get it as a product. So I'm going to rewrite this as x squared minus 9 over x squared plus 5x plus 6. That stays the same. So now I got the division over here. I'm going to put multiply. Now I'm going to flip it. So now I have x squared minus 2x minus 8 at the top divided by 4x squared minus 12x. All right, now I can either factor or reverse FOIL my numerator and denominator, which will help me cancel out terms during the operation. X squared minus 9, if you recall, is the difference of two squares. So I can rewrite this as x plus 3 times quantity x minus 3 over, let's see here, I got parentheses, parentheses, I got x, x. The positive 6 means it's going to be the same sign. The plus 5 means they're going to be both positive. And it's going to be 2 and 3 times by, so there are parentheses, parentheses, I got x and x. Negative 8 means they're going to be different signs, and it's going to be, what, 4 and 2? And this last one can't be reverse foiled, but we can factor out a 4x out of here. So I can go 4x, and then it's x minus 3. Okay, so I can cancel out my 2x, or x plus 2 and x plus 2. I can cancel out an x plus 3 and an x plus 3. And I can cancel out an x minus 3 and an x minus 3. So what I'm left with is x minus 4 all over 4x. Okay? Last example. I have 3x squared plus 24x plus 36 all over 6x plus 9 divided by x plus 2. Okay. Let's do this. So I'm going to rewrite this as 3x squared plus 24x plus 36 all over 6x plus 9. This doesn't change. I'm going to go to multiply. And since we recall we have x plus 2, it's almost like you're saying it's x plus 2 over 1. So I'm going to rewrite this as 1 over x plus 2. Okay. I can, in that numerator of my first fraction, I can factor out a 3 here. So I'm going to go 3 over x squared plus 8x plus 12. And in fact, I can factor out a 3 in my denominator. So it leaves me with 3, which gives me 2x plus 3 times by 1 over x plus 2. The 3's cancel. So then it means now I can try to FOIL my numerator. So I got x and x. The plus 12 means they're going to be the same sign. The plus 8 means they're going to be positive. And so 6 and 2 all over 2x plus 3 times 1 over x plus 2. And if I look, x plus 2 cancel. And I'm left with x plus 6 in the numerator and 2x plus 3 in the denominator. And that is multiplying and dividing radical expressions. Hope this helps. Until next time.